Hello everyone and welcome back to Handmade Hero. It has been, well, I suppose it hasn't really been any time for people who are watching this video on demand because they'll just see these in order, but if you watch the series live, then you know that we've been on break for a couple weeks. And we're back now. Right before we went on break, what we did is we actually isolated and optimized our renderer. So it's actually a standalone component now you can use to make really anything you want that's a sprite renderer. And we also went through the work of making it use sprite array, well, texture arrays to represent the sprites, which we did because it's a fairly widely supported feature that allows you to get off of the single draw call per sprite kind of an issue that we had before. When we just literally translated the renderer from a software renderer to a hardware renderer, one of the problems you get is that you end up changing textures every draw call because every sprite is its own texture, and that's just not really something that all video cards can support. Now, like I've said before, there actually are plenty of cards that can. Changing textures per quad issue is actually pretty easy on higher end cards. The problem is that it doesn't scale to all sorts of stuff. So there's like Intel chips that don't support it that are pretty common in the wild. There's probably phone style hardware out there that you'd have trouble with. So texture arrays is one way to kind of almost get the same benefits as being able to quickly change the texture pointer every primitive without actually using that feature, which is not ubiquitous. So just to refresh everyone's memory, we ended up with some pretty nice results here, and we've got like one more thing I think to do in the renderer before we're done. But if we take, you can see I was working on the Meow hash. This is the only machine I have with AVX on it, so I had to do some Meow hash work on this particular machine. Yeah, for those of you who don't know, I posted Meow hash on Friday as well, which is pretty fun. Meow hash is the hash we now use at Molly Rocket that I developed while Handmade Hero was off. Actually, I just developed it this past week because I was looking for something to fix our slow hashing. It's the fastest hash I think that there is right now. I don't know that there's a faster hash out there that actually can pass all of all of the current hash tests like SM hasher. And practical collision tests like large data sets and verifying they don't collide. It's pretty cool, so check it out. The source code is licensed permissively, and it's up on, there's a GitHub for it here. The entire thing is just in meowhash.h. So if you're interested in fast hashing, it's not cryptographic. It's designed for data comparison. So it's not the kind of thing you use for security. It's the kind of thing you use for like data deduplication. But it's designed to hash huge blocks of data extremely quickly, and it actually hashes. It's one of the only hashes I'm aware of that hashes well higher than memory speed. So if the data is in cache, it actually hashes significantly faster than the speed of main memory. Whereas main memory is usually like an upper bound for most hashes. If things are in cache, they don't hash any faster. Meow hash actually hashes even faster in cache than it does normally, and it beats all the hashes that I've seen, even at memory speeds, because a lot of hashes can't quite hit memory speed, but Meow hash does. It fully saturates. Anyway, so what I was going to say is when we left off, we made like a little renderer test here, and this thing is just oh. All right, well, that's not a very good sign. Did we leave a bug? What's going on here? I thought we left everything in a reasonable state. Did we totally cheese out or something? What am I forgetting? Huh. Well, I guess we've got some work to do. Apparently, we made a change that we didn't run before we left last week? Is that true? Well, let's take a look. All right, never mind. Forget the recap. We've got work to do, folks. That's weird. We don't usually do that, or at least I don't think we do. Let's compile. And now it looks like we crash in this. Okay. Someone want to tell me what's going on here? You know, Visual Studio was updated in between the time we left and came back. Is this some kind of what's going on here? Someone tell me this is someone tell me there's an explanation for what just happened. Very grumpy right now. Very grumpy right now. Why were we crashing in OpenGL managed textures, people? What's going on? I mean, I'm assuming the only way you could really have a crash here is if this OpenGL managed textures, I mean, all it's doing here is just passing two things in. I'm not sure what really could have been the problem there. I mean, OpenGL managed textures is just a function, right? Maybe it got, well, no, I just looked at it. It didn't get inlined. Did it get inlined? Yeah, it looks like maybe it did. All right, hold on one second. I mean, it's really weird that we would crash like that, and if you recompile it doesn't crash. Does not make a lot of sense. I probably should have run that executable outside the debugger to see if it was the debugger that was doing something nasty there. So this is the entirety of what OpenGL managed textures does, right? It just does a dequeue, OpenGL allocate, and then enqueue free. That's the entirety of that process, right? So if we actually set a breakpoint in this line here and run to it, yeah, I'm not sure what's going on there, because in theory that should just be calling OpenGL managed textures, but it looks like it actually went ahead and rearranged this, probably because of just being compiled with optimizations, right? So I'm guessing that if I compile without optimizations on, so it won't inline that code, when I actually go here, I'll actually jump into it, yeah. So I'm not sure what we could have done wrong there. That's gonna bug me. I shouldn't have destroyed the executable, I guess, because we probably can't produce that particular executable again, would be my guess. Well, and this isn't multi-threaded at this point, right? I mean, I don't think the initialization code just processes messages and doesn't ever call the renderer. So it's really, there are not two actually active threads as far as I know. Well, all right. I guess we'll have to postpone that till we see that crash happen again, or assume that the debugger was doing something weird there. I really don't know what that is. And it was reliable. It happened in both programs. It happened in both Handmade Hero and in the standalone renderer. You know what I'm saying to you? Well, all right. We're just going to have to leave that for now. Anyway, what I was going to say before we got rudely interrupted by that crash, which I guess we don't really know why that would be happening because a fresh compile does not produce the bug. And presumably these were the same build before. All I was going to say is we got some pretty good results here. There's only really one thing that's a little ugly about it. But I think that's something we can leave for a little later on. If you look at the render test and Handmade Hero, they both now get very good throughput, so you can have lots and lots and lots of sprites. Well, very good is not probably the right term. Adequate throughput for our needs, rather than being held back. So now we can just spam tons of grass out if we want to, or do, you know, who knows what we're going to want to do. But here you can just see a test of just throwing a bunch of grass sprites, and there's like hundreds and hundreds and hundreds of them all over the place, and it's fine. That's what we want to make sure we can achieve, right? We don't want to be in situations where we have to worry about we put too many grass sprites out there or something. So that was good results. I'm glad we got that. Now Handmade Hero doesn't have to think about it so hard. There are a few things left we probably want to do on the renderer that don't have much to do with the pulling it out part. That part's pretty much done. I don't think we have to really do anything else. We got what we wanted out of that. But now what we would like to do, moving back over to Handmade Hero, there are a couple of things that would be nice to do that we just haven't done in the renderer yet because we only just finished that sort of using texture arrays part of it. And that is, first of all, we no longer support large textures because everything has to fit inside the texture array. So for example, if we switch back to the cutscene, which I've done here, what will happen is that all of those textures we were going to use will all be trying to draw textures that are much too large, or who knows what happened, right? And so, yeah, we can look here and see when we go to allocate the texture, the problem that we're going to have is that the texture itself will not actually fit inside the texture array. So what's going to happen here, and I probably should compile in debug mode so we can set this a little bit more cleanly, but what's going to happen here is when we get down into the code that would put the texture into a texture array, it can't because the texture is too large. So what ends up happening is right here, it's going to come into this routine. It's going to ask for, well, it's going to ask for, you know, oh, I'll put it in texture index 45, like that's the slot in the texture array. But the width and height are these big cutscene plates. And so what's going to happen is OpenGL is going to be like, I can't put that into here because it's only 512 by 512. I can't put something that's 2345 by 1152, right? So what we need is we need to have some way, well, okay, there's a couple of different ways we could approach this problem. If our goal was to primarily be about drawing large textures, so let's say that a cutscene was not the only time we were going to do that, and we had lots and lots and lots of things in the game that are all about drawing arbitrarily big stuff, right? If that were the case, we'd probably want to do something where we break large images up into tiles and then reassemble the tiles, right? Because we wouldn't want to break our nice clean render path that doesn't have to switch textures for that purpose, right? We would want to be able to just keep drawing with tiles everywhere, and that would be much more powerful. But we already know that the only times we really care about this, there's like 5 or 6 textures total, in 5 or 6 plates total being drawn on the screen. So really we'd be creating an entire system to deal with something that really only happens once in a while, and certainly isn't a performance bottleneck because there's only like 6 things on the screen. So changing textures 6 times in the render is free, right? It's not something we care about. So what we should probably do here instead is just have a path that when we see large textures, we handle them specially and let the card do its standard changeover each time with those large texture calls, right? Because we don't even have to detect it, really. We know when that's happening, right? We know that our cutscenes are the things that use them and our game doesn't. So we don't even have to detect it. We could, because the texture width and height are packed into the texture handle the way we did it. So it's a nice convenient way for anyone who wants to switch either way, right? But we don't even really have to do that. If we wanted to, we could just make a special call called cutscene plate. That's a separate kind of render state. And that could switch textures every primitive, the way that we used to do it. So we can just bifurcate the path. And I think that's a much smarter option here, because that's going to let the card do the work for us in a more efficient way than if we were to do it ourselves. And so we'd just be slowing things down by going the other route, I think, and actually being counterproductive. That's my assumption anyway. So I think that's thing one we want to do. There's one other thing we want to do, and you can't really see it much here, but if you look at what we're doing behind the scenes, we are not mip mapping our sprites, and we probably will want to mip map our sprites. What this means is that as the sprites scale up and down, right, the graphics card can only do bilinear filtering. I mean, that's not true. We could have it do much better filtering if we wanted to, but in terms of the fastest possible drawing, bilinear filtering is the thing that's on the fast path. It can do that basically for free for us. Like, bilinear filtering is more or less free. Bilinear filtering gets you a scale factor of 2, okay? So if our sprites are 512 by 512 at maximum, and when they render, we could shrink them down to 256 by 256, anywhere between 512 by 512 and 256 by 256, the bilinear filtering, because remember, it blends between 2 pixels, that's the halving factor that would get down to every pixel represents 2 pixels in the original. Every pixel drawn is 2 pixels, right? There are 512 by 512 pixels. 256 by 256 is the size we're rendering. So every single pixel we render corresponds to 2 texels, or 4 texels, right, in X and Y, but in terms of what we're blending between, right? So 4 texels, 2 left to left to right, 2 top to bottom. So at that scale, we would produce clean, usable results. What happens when we shrink below 256 by 256 is now every pixel we draw represents 3 or more texels worth of area in the original image. Because we will only filter bilinearly, we are missing some of the data. And that's why you get that sparkly, like, weirdness going on when you shrink things down below that size. Now, it's hard to see, unfortunately, because our renderer is actually pretty good. Oh, I should probably turn the optimization back on here. Our renderer is pretty darn good. And so what ends up happening is that because we've done a lot of work to carefully use things like multi-sampling, and because we're very conscientious about depth peeling and all this stuff, what ends up happening is it's really hard to see that this is happening because we've got other things helping to eliminate those sort of jagged pieces. But they're still there, and if we turn off the multi-sampling, we would see it, for sure. And so we get into a situation where, yeah, if we shrink things down enough, they probably will start to show some objectionable artifacting. And so because doing mipmaps is relatively free, we probably should just do even at least a crappy version, something that just does bilinear filtering when we submit the texture, so that we can have reasonable quality for downscaling, right? And yeah, again, I don't. It's hard to motivate because thanks to the fact that we have multi-sampling turned on, we may just never see it. I mean, I could motivate a different way, which is that if you downsample, then there'll be less texture footprint used when you in the texture cache when you actually go to draw those things, and that could be a speed win for us. I don't know. It's hard to say. So yeah, 6.5 does the other. The much more pressing thing, in case you can't tell, is the cutscene issue, because that one actually prevents our cutscene from rendering at all. Whereas this is a quality issue, and as you saw, it's a pretty hard quality issue to motivate, because once you turn on, because you have bilinear sampling, you can shrink down by half, and then because you have multi-sampling, you get an additional factor below that probably, right? Because the multi-sampling will clean a lot of that up. To be honest with you, I don't think it should be really cleaning it up that much. So as I'm saying that, I'm not sure why that's happening. It's just the edges probably really that it would clean up, but that's probably what you would mostly see. I don't know. I actually would have thought we would have seen it a little bit more, so who knows? Hard to say. I mean, another thing that could be happening is maybe the card's just generating mipmaps for us. Because they can do that, actually. Like, for example, let me see here. Sometimes there's things you can turn on that will just do that. Yeah. Like that force mipmaps. I'm not seeing it on here, so maybe that doesn't happen anymore. In the old days, it did. So I don't know. We can do some tests to see. So maybe we don't even really care about mipmaps, which is kind of crazy that it's that high quality sampling. And maybe the other thing I guess is maybe we're just not drawing things large enough. So maybe a lot of them aren't being shrank past double. And if you don't shrink past double, then you're okay, right? So yeah, I don't know. We'll go from there. Okay, so let's start with the thing that actually we know makes a difference, and then we can debate the other part of it a little bit later. So if we go into Handmade Renderer OpenGL and we look at where we're actually submitting all of our draw calls, right? So we look at the part here where we're actually doing like this, render entry textured quads. You can see the way this works is, it sets the scissor rect up, it looks whether or not we need to do depth peeling, and then once it's ready to go, it just says, all right, go ahead and draw all the elements. This is how we used to do it, right? And now we're going to be like, nah, do it this way, because we want to be able to just have everything drawn without the texture handles, right? Because we're just going to use the indices that are baked in there. So all I'm saying is that, look, because it's probably free for us to do so, why don't we just make it so that we can still do this texture switching each time? And there's a pretty easy way we could probably do that, right? If we wanted to be maximally piggy, we could actually just use this and have the texture array be specified each time, right? So that way the texture that we're using to draw from would just be specified. And then we could just issue multiples of these and go from there. Now, the reason that that's a little bit risky is because there's so much stuff here that you don't really need to do, right? Like, ideally, we would want it set up the same way we had it before, where we change textures each time. So I'm a little reticent to do that. And I think what might be better is if we just look at the renderer itself, the way that it specifies this stuff, you can see that the textured quads that we send down, we're sending down this setup, and we're setting down this information. What we could do is just say, look, why don't we still specify a texture array? Like, let's just still send down an array of textures, and we'll just set that pointer to either 0 in the case that we currently have, where we just want to use the texture array and draw a batch, or we set it to non-zero and point to one texture per primitive, and then draw the primitives the way we used to be drawing them. That seems compelling to me because that allows us to then have all of the setup be amortized. So the cutscene can still draw everything in one batch. It just has to issue multiple draw calls, but it can amortize a setup cost. And then the sprite path can do it as it's doing now, where not only does it amortize the setup, but it actually does a single dispatch for the entire batch without having to do multiple dispatches, right? So that seems pretty good to me. I think that's the way I would like to go with it. So yeah, so what I'm going to do here is say, all right, let's say that there's something here like a texture pointer. We've got the concept of a renderer texture pointer, and if I remember correctly, that's sort of something that we have in here, right? This renderer texture. And so we can just use this stuff that's here again and say, look, there's renderer textures that are special. We'll deal with that somehow. But basically all you really need to know is, look, there can be a renderer texture specified in here, which is texture array. And this will just be, look, texture array is 0 if, and I guess it's called, let me call it textures. Textures is 0 if you're using the default texture array, single batch render. Textures points to one texture per quad if not. Right? And so then what we could do here is say, well, let's go ahead and do an if and see which one we actually have. So when we come in here and we get the entry out, that will have this pointer, and we can just switch on it. So we can say, look, if this, well, if I could spell textures properly, if we have one of these pointers, then we need to do the old school dispatch, right? And if not, then we can do the faster nice dispatch, right? So something like this. So all we need to do now is figure out a good way to communicate those textures through and special case them. So when someone asks for a texture that's going to be large, they get back a special handle that's, you know, in some little pool that we reuse. And those are for large textures only in the cutscenes. And then we've got a separate case where we handle the texture array fast path, and we just switch between those as necessary. So I think that's a good way to go. Now, we need to make sure we can draw the same way with both of these. So you can kind of see here, like, we want to do the same sort of stuff here. Since we're looking at indices, we need to make sure that all of this, it looks like we updated this routine actually to use indices, so it seems like everything's actually set. So really, the only thing we have to do is just look here at what's going on. Maybe I'll call it the same thing that we were sort of calling it before, like that. And that way we can just say, all right, whichever one we're going to do, we'll grab it out of here, and then we'll bind it and go. Now, when we grab this rendered texture out, there's going to be an index in it. And that index, in this case, we can just pack the actual textural handle from OpenGL into that index. That should just work, I think. I can't think of a reason why it wouldn't. And so I think we can just go with that. I think that will be sufficient. So really, as you can see, very simple here. It's really easy for us to handle this two-way dispatch. So I think this is, again, just getting good feeling about that decision. It seems like a really simple way to handle this one special case because, again, it's not the bulk of our rendering. We don't want to contort our render path a bunch to deal with it. So we want to kind of have the easiest possible way to just shunt those special large texture calls off to the side and try not to make them ruin any of the sort of mainstream high throughput rendering that we need for the in-game stuff, because it's just for the cutscenes. And they're very simple. They're just a few layers. All right. All right. So what we need to do now is actually figure out how to get this array set up and ready in the case where we need it, right? So there's two parts to that. One is detecting these textures that need special treatment and doing something with them. And two is actually having space to put this array so that we actually can use it, right? We need some way of dealing with it there. So there's a couple ways we can do this. I'm not sure exactly how we want to do it. I'll kind of just start feeling my way through it, and we'll let it shake out to wherever it's going to shake out. Since we know this is always going to be a small number of textures, we're talking about like 8, 16 textures tops. I mean, I think let's actually get a beat on that. I mean, it looks like if these are all of our cutscenes that we sort of threw in there, right? 1, 2, 3, 4, 5, 6, 7, 8 is the highest. So we're talking about 8 texture handles total, right? So what we could very easily do is allocate a small pool, let's say 16 texture handles or something. And we could just go through them in like almost a round robin fashion or something equally crappy. Would probably get us by, possibly even just to ship. Like it may never get more complicated than that. Because again, like we only care about this in this specific case. So maybe we'll care about it more later and would have to do a better scheme if it turns out that we do something else at some point where we need to think harder about it. But as far as I know, like the cutscene is it. And it is what it is. Like we're done with it, basically. Like, you know, we'll be playing some audio over it, but other than that, it's not like we did a fake version of the cutscene and then we're going to do the real version later. It's like it is the real version already, so I think it's just done. And really would only be tweaked. So I think we could safely say that a 16 texture round robin scheme or something where we just overwrite textures in that order or something would probably be sufficient. And so it's just the asset system that really has to be aware of that. So that sounds right to me. Yeah. So I think we may also want to well, all right, let me just do it, and I'll show you. I was going to say something about how we may want to actually use an index into an array inside the renderer for other reasons. So actually, let me, well, since I went ahead and blurted it out anyway. So this is probably not quite right. it's probably going to be something more like that. Right, so we're probably going to do something more like, hey, I need the special texture handle for this special texture. And, you know, it'll use the index in a way that makes sense there or something, right? So we'll deal with that a little bit later, but that's probably actually what we will do. So let's go ahead and push a little bit further down that path. So if we wanted to make this render texture stuff a little bit cleaner here, so let's take a look inside the renderer where we actually push on the quads and figure out how we would deal with this. So inside push quad, you can see here that we sort of do a get, a current quads thing here. And what we want to do is take a look at that and figure out whether we need to specify special quad textures or not for something. And so I think what we want to do is make that, again, be something that we do probably specially. It's a little bit hard to say, but probably specially. So when you actually do like a push cube or something like that, you can see here that we do a get current quad. And when we do something like a push sprite or a push rect, we do that get current quads, and it makes sure we get one that's a particular size, right? And so I think all we really have to do is make sure that the get current quads call is smart enough to go, hey, if you're switching from rendering something that's using the fast path to something that's using the slow path, I need to create another batch. Because it already sort of does that, right? When it looks at max quads per batch, and it just goes like, oh, all right, you've exceeded them, so stop. And so that, I think, is what we would really need to do. In here, where we do get current quads, what we could do is say, look, you've got to pass the texture handle down to us so we can check to make sure that it's not going to conflict or something. As we start to worry about how expensive it is to do these current quad calls, we may need to do more than that, but let's just assume we're going to do that here. So we'll say that you pass a renderer texture here. So you say a quad count and the texture that you're planning to use. And then what we can do is say, well, okay, if there were current quads and the group current quads has quad textures, I guess I should say, and it doesn't match, like we sort of need a thing which says that the quad textures is either on or off based on whether we want it to be on or off as well, right? So we might just, I guess, be a little bit more explicit about that. Say current textures, and we could just say current quad textures. So, if that's not equal to 0, then currently we have textures. And then we need textures for this one. We could say, like, this textures is something like needs quad textures, right? We could ask if this one needs it. And then we could say, if current textures is not equal to this textures, then we also have to flush, right? So basically that's just a way of us saying, look, we've got a batch. We always jam things into the current batch as far as we can go. But anytime we hit a blocking condition that's like we can't do any more on this batch, then we flush and make a new batch. So we're just adding a new check here to make sure that if we need to switch between texture arrays and large textures or vice versa, that we flush that batch and go from there. Now, this is actually out here because it doesn't depend on whether there's current quads or not. And we do need to know this because we're then going to have to create one of those arrays here if we need it, right? So, oops. So we're going to have to go, all right, the current quads needs to get a quad textures here for whatever the quad count is that you're actually going to output, right? And so that becomes, again, a little bit more persnickety. Now, what I'd like to do, because I like the way we were setting up before, I think I might want to do it... trying to think here. I mean, I think I might want to do it kind of the same way we were doing it before. Where we just use the vertex buffer and index buffer that are kind of inside the render group there, right? So like, I'm sorry, the render commands. Where's that at? There it is. So, you know, this game render command struct has all that stuff in it, like the push buffer and so on. And so it feels like that's probably a natural place to put it, where we just have an array there for that purpose. You know what I mean? So we would have in here sort of a texture array that's like, you know, max texture count. And inside the render texture stuff, we just have I don't like using the word texture array, even though that's what it is, because it makes it sound like the texture array that's inside the render, which it's not. So this would allow us to sort of append those on. And I think that's how I want to do it. So if we just make one more array here, that's the same as we used to have. So really we're just restoring the old feature. We're not even really implementing something new. I'm kind of saying, look, it's a little bit different, but it's mostly the same. We just have a backband array. It's got some information in it for textures. It's small. You know, this is maybe 64, 256, something really tiny, because we know we're only going to have like 8, 9, 10 of them. So, you know, it's not going to be a large number of these things. And so I think that's really all we would be talking about here. So we just say, all right, you know, the quad textures is really just going to be a pointer into that array. So we would say, all right, the quad textures is whatever the commands quads textures is, plus whatever the offset was at that point. So it'd be like commands quad texture count, right? It's just going to point in there. And then people can stack those up in there. And similarly in here, we would have to double check like that the quad texture count plus the quad count here is not going to exceed the max quad texture count. Because if it does, then you can't render, right? You've run out of steam. So you got to double check that, you know, when we look at the quads we're actually going to return, they'd better actually be valid for the number that people are saying they're going to draw. Right. So this also is predicated on the fact that you're going to actually use it. So in here, right, we know that this is going to be if this textures, I mean, well, actually, you could do it this way. Right? It's a little ugly, so maybe I'll leave it like this. So if you need textures, then you will get them. If you don't need textures, you won't. So by default it's 0, and then if you actually want the textures, then we'll give you the textures. And similarly here, either you don't need textures, right? So if this is 0, actually I should say, if this is true and you would exceed, then it's bad. But if this was false, then it's okay, right? So we won't trigger, because if you're not using textures, we don't care if you would exceed, right? So then we just need to answer this question, which is, does a particular texture need quad textures? And we can make a call that does that check pretty easily. So we'll deal with that in a second. In the meantime here, we could just say, and same with get special texture for, right? So now let's take a look at what else is happening here. So in this case, we need to be able to, I assume we have a null texture, do we? Guess we don't. So I don't actually know if we, oh, well, I don't actually need that there. We actually passed the texture there. So I don't remember if there's places that we pass a null texture. We probably do, and so we may need to deal with that in a second, but we'll cross the bridge when we come to it. So here you go, as an example, right? There's no texture here. So we need like a null texture for these circumstances, which seems fine. In most cases, we should probably have one. It's just the rect, like the sort of debug drawing tools that don't use that. Oh, well, you know what? They use group white texture anyway. So in theory, we could just pass that because that is correct. So actually, that seems fine. But everyone else will have a texture, and so most of the time, anything that we actually care about will be using an actual texture here. Let's see. Get current quads does not take too long. Yes, that's true. Where is the texture handle? Bitmap texture handle. And get current quads for the white texture. Oops. Would just be here. So I think we're almost good. All right, so I think that's all good. We just now need to have an understanding of when those get created, right? When they're larger. So needs quad texture is probably not the best name for it. So I think we probably want to have something more like special texture handle, like is special texture, right? Is probably more what we're talking about here. And inside the renderer, this is something that we're gonna wanna be able to answer really easily, right? So if you ask if a renderer texture is a special texture, it's gonna be something like, you know, if the width and height are different than the dimensions of the texture array. So this right here is really what we're talking about. So we probably want to have this be past the render group, just in case in the future it becomes a parameter that we don't necessarily know at compile time. So right now we won't actually use this, but we would potentially use it in the future, right? So the result here is just going to be if the texture's width is greater than the array dim, or the texture's height is greater than the array dim, then that's all we need to know. It's going to be special at that point, right? And so we could do other ways of determining it, but right now that's dispositive, so we can probably just say done. We could do other fancy things there. So for example, we could have a break in our indices. We could say that indices like above the high bit set are special and below the bit aren't or something, but I'm just not going to bother with that. I'm just going to say, look, it's based on the width and height for now. And we could change that, right? We could change the indexing scheme in the future. Well, okay, you know what? No. Now that I say it, I'm going to take that back. And the reason I'm going to take that back is because if we do it with the index, we would guaranteeably never have to pass a group here or look anything up. So if we did something more like this, that would allow us to say, oh, there's a special texture bit here that, you know, determines whether or not the texture is a special texture. We never need to know anything about where it came from or compare it to anything. We can just do a quick bit check and off we go. That does seem kind of compelling for a lot of reasons, right? So if we look here, we've got two U16s and a U32. So like, yeah, we could just say, hey, there's a special texture bit. And it's, you know, that or something, right? And that would allow us to really quickly determine it and go from there. So yeah, I mean, I guess the only thing we really need to do at that point is when we do get special texture handle for, we now need some way of resolving those textures. And when we go to submit textures, we need a special way of saying that those textures were ones that were going to go down the special pipe. So that seems good to me. And there's a couple different ways we could do this, but we'll talk about that a little bit later. All right, but I'm reasonably happy with that. So if we take get special texture handle for, and we throw that in here just real quick. So this is not really implemented yet. When we actually send a renderer texture down, it should be able to return us that handle. We're going to need to pass it probably the OpenGL context stuff because it's probably going to look into an array of some kind. But other than that, it should be pretty straightforward. Let me do this here so we can see it as well if and when we step into this code to debug it. So we'll do it a little bit more like this. Oopsie, that's not good. That all seems reasonable. So I think that should be pretty much it for the binds for the user side in terms of like outputting these textures. And hopefully, if I didn't screw anything up, everything just works when you're not using textures of that size. So basically, you know, the render test suite, the game as it currently exists should be fine. And so they're just still running through the same path, and that other path is just sitting in there not being used. When we switch to the cutscene now, of course, we'll still get the exact same error that we got before, because we now have to actually take the step to create our large textures as special textures, which we have not done. So now we just need to do the last part of this, which is to make the asset system aware of situations where it's loading a texture above the texture array size that it's specified. So inside the asset system, that's really where this stuff now gets a little complicated, is we just have to have, when we load the assets, we have to have the texture understand when it's special and when it's not, right? And so when we do all of this stuff, it can just pass through because the texture handle itself says whether or not it's special. So it's really the point where we refer to the texture that it makes that it becomes relevant, right? So right here, when we do our refer to texture and we use next free texture handle, that part right here, this right here, is the part that's going to need to understand that it has to use a separate texture pool for large textures. And so what I want to do is expand the renderer out, or expand the asset system understanding a little bit. And don't forget, one of the things that's interesting about the way we're doing the asset system here is we can now massively simplify most of what's happening in the asset system, because almost all of our textures in it now are fixed size for the most part in terms of how we're actually handling them, and they're being backed by storage in the renderer. So we really don't need to have most of the code that's in the asset system anymore. It can just be backed by texture handles and be done. So this to do is very much correct, and that's sort of a separate issue. But what we need to do here is have some way of saying, all right, there's going to be two ways that this is going to happen. Really, this call can be the same, but what we want to do here is say that there's a free texture handle. I don't know why that's a U16, because I thought that it was actually a U32. I think that may be old news at this point, because there's no reason it has to be U16. Now, you could never use 32 bits because there's no way the graphics card has enough memory to have a texture array that's 32 bits worth of indices. So you can kind of forget that in this day and age. Maybe someday in the distant future that will be possible, but certainly not right now. So if we look at an actual renderer texture here, I'm pretty sure, yeah. So, right, at least right now we're not doing that. Now in the future, maybe we want to use a 16-bit index and use the other 16 bits for something more useful, because we're also not going to have 65,000 textures loaded any more than we were going to have 4 billion textures loaded. Both of those are ridiculous for our current hardware specs. So that's not an issue. But at the moment it is 32 bits, so there's no reason to be casting. We should save the casting for when we actually need to do that. So let's do this here. We'll start by saying that in the case where the texture is not special, we will do this. And in the case where the texture is special, we will do the, we'll get it from a round robin scheme. So in here, we would just say next special texture handle, and we will want to mod that value by the texture, we'll want it to wrap, right? So what we'll do when we assign this is we'll say, well, you know, use the next special texture handle plus plus, and we want to say if the next special texture that you would have used is outside the range, then we would reset it back to 0, right? So in here, we'd say something like max special texture handle count or something like this, or just special texture handle count. And so we just assign and wrap. And so it will reuse the textures as it goes in that way. Okay. Now again, this is not really correct yet because we still haven't dealt with sort of how the asset system as a whole is thinking about these. And that's because the asset system still stores these textures itself, which we don't really want it to do. And so we're going to probably fuss with that a little bit in the not too distant future, but that's a separate issue. So we've got the texture handle here, and the texture handle is going to be assigned in one of two ways now. And what we're going to do is, now is finally the time that we might want to do a dimensions require special texture handle or something like this, right? And so what we can do here is say, look, let's pass the width and height in, and we'll ask, does this texture need special handling according to the system? And you know, now that I think about it, this is probably a determination best made by the asset system. And so the asset system itself can say, when it starts up, it'll maybe create the texture array with a specific size. That's how it will do it. So in the future, we could make that more flexible, where we create different sizes of texture array based on, for example, what resolution we're running at. So we probably want that feature to be something that's internal to the asset system itself, not something that the renderer cares about, because the renderer really doesn't care what size you make the texture array, as long as it fits in memory. So it's probably something better done as sort of out here. So if we pass the width and height in this case here, like so, then what we can do is we can compare those exactly like we were going to do before. Now, what we will say here is, in the future, probably make this dynamic. But for right now, we don't have to. And so all we really do here is exactly the thing I was going to write before in the other part of the path, which I decided, nah, let's make it so the handle knows. And so all we're going to do here is say, look, if the width is greater than whatever the texture dim is that we sort of hard-coded now. I guess why I say let's make it dynamic maybe in the future, because there's really not a lot of reason for it to be hard-coded. It'd be pretty easy modification for us to make it so that you pass it when you start the renderer up, you know? So anyway, we'll just say, look, there's a width and height here, and the texture array dimensions, we're going to test against them. If you exceed them in either case, then you will need special texture handling. So you go through the special texture path. Otherwise, you don't. Right? So I think that's really all there is to it. And off you go. So here where we do refer to texture, we're going to go ahead and put the texture handle in here. And what we need to do now is the texture handle itself needs to get the special bit ORed in there so that everybody knows that it's a special texture and not one of the ones that goes through the regular packing path. So in here, when we know that it was a special texture, we could do something like this: texture handle equals make special texture, like that or something. Something like that. And then inside the renderer, it's got a way of tagging that out. So you say, okay, pass me in the index, and I'll pass you back the thing that says that it's special. While we're at it, we will assert that the index doesn't already have that bit set. Because obviously if someone actually was trying to use those bits somehow, that's bad, because that's reserved for our use. We need to make sure that it's not there. And so we're going to keep that like masked off, right? So we need the asset system itself to have this special texture concept now in it. So in addition to next free texture handle, this is going to have next special texture handle, and it's also going to have special texture handle count. And these are going to be things that are at the start, when we initialize, that we have to just know, right? They have to be created in the renderer, and we have to just know exactly how it's going to work. So when we go to allocate the game assets, we need to set up the special texture handle count. And presumably our renderer texture queue, for example, could have that on it, since that's something that it knows about. And it'll just say, look, this is how many special textures you're going to get. So deal with it, right? I'm not sure if that's the best way. I mean, really, Handmade Hero itself probably wants to just specify that at startup, how many special textures it wants. And this information kind of has to get trickled down here. So I feel like to a certain extent, it's like this is largely sort of a communication thing that has to happen. If we take a look at the texture op queue here, since that's the thing that people would be looking at and would have a handle to, oops. In here, I think it might make some sense to put the information about how the textures are set up, because then everyone knows what that is. So I might say, look, let's say that in addition to the texture queue operation, in here you can also get a thing that says your texture handle count, like your normal texture handle count and your special texture handle count. And so in here you just know what those two are. You know what I'm saying? Furthermore, since the texture op queue is there, I guess that means I could just get rid of that, and I could just say, all right, let's make that be something that happens in here. So when we actually do the load bitmap function, we could do that. Now, one of the things that I'm not sure about is, because this, I believe that this is always, load bitmap is always called synchronously. It's not inside a task, so I think it's safe to just use regular increments here, meaning these things are not hit by multiple threads at once. We don't have to be careful about whether or not they're like actually gonna get out of sync incremented and get some kind of bad over allocation situation happening. Because I'm pretty sure that basically the only thing that happens on the deferred thread is just the load decompress, or the load prepare stuff, right? Is all that happens. So I think that probably is irrelevant. All right, so what I want to do here is just say, okay, this is actually going to be texture op queue special texture handle count. And so that's just fine. And off it goes. So really all we need to do now to make this work, I think everybody is treating it reasonably. Also, I can put this assertion here, like assert that the next free texture handle, the one that we're about to use, is less than the asset's normal texture handle count. And so we can also now check to see when we overrun, if that makes sense. So now all we need to do to actually bring this scheme together and start debugging it and testing it is we need to have a way of, when we start up OpenGL, allocating some of those special texture handles so that there actually is something there to use. We're handling them all up and down the pipeline now, but that doesn't really make any difference if nobody ever allocates any of these to begin with. You can't very well render with a texture you've never allocated. Now, where do we do that? Well, we kind of know because, remember, we ran this before and crashed. Well, we didn't crash. We hit an OpenGL error that said, hey, you're trying to put a texture into a texture array that doesn't fit. And so inside allocate texture here, where we're putting this in, what we can do now is actually control this very cleanly, right? So we can take back this core code here, where we specify the GL text image, and we can say, look, this is now going to be predicated on whether or not you're using a special texture handle or a regular texture handle. So the same thing would happen here, like so, and we could maybe get these off of the op queue as well, depending on whether or not we have that here. We could look at that to sort of collapse those down into something a little bit more usable there. But again, here the way that we would do that is we would just now, instead of trying to generate a texture handle at this point, we'd actually just reuse the texture handle and overbind it. So we'd replace the image that was in there with the new image that we were getting. And so I think that's pretty much it. This stuff here can actually happen. I don't know why. I feel like bind texture 0 should probably just happen out here to clear out that just in case. I'm going to leave it like that for now. So really what we want to do is the exact same thing we're doing here. So we want to move this gen textures out, right, into something we're going to deal with a little bit later. And similarly, these text parameters, the text image is separate from the text parameters in OpenGL. So respecifying the image shouldn't clear these out. So we probably don't need to specify them again either. We can probably specify them once when we create those textures and then just run with it. So really, I think all we need to do is this path here. So what we can do is say, test the texture for specialness, right? So in here, we can just say, all right, is it a special texture that you're trying to bind? If it is, then what we need to do is create the index from it. So here, where we were just getting the index out raw, what we can do now is say that we're going to take and mask off that texture special bit. I feel like that should just be an XOR, probably, huh? You know, my brain is just not one of those brains that does algebra well, like just period. So like really basic stuff that you would think I would have known because I've done it so many times, I still oftentimes have to think about. For some reason, things like geometric things, I don't. So a lot of times I'll just be like, oh yeah, well it's just like the cross product dotted with this, and like my brain just like works out the entire geometric construction. I can just say the whole thing because the practice has built up the ability to jump several steps forward. Even with fairly complex geometric things like quaternions, sometimes I can do that. Algebraic things, it's like the opposite. The simplest, stupidest thing, like, is an XOR the same as an AND not? Is something that someone who's been programming for 30 years would probably just know, but I don't. I have to actually sit there every time and go like, okay, so an XOR, right, let's do it. An XOR, if it's 0, 0, it equals 1, right? Because it's exclusive, I'm sorry, if 0, 0, it equals 0, so it's exclusively OR, right? If it's 0 and 1, it's 1. If it's 1 and 0, it's 1. And if it's 1 and 1, it's 0, right? Because it has to be exclusively ORed the thing, meaning you can't have the same value in any one lane, right? Whereas an AND with a knotted second parameter, well, an AND with anything that's 0 is going to be 0, right? So an AND in this case, yes, so this one's different, right? So an AND not in this case, like if I not that, that will become a 0, so this would still be 0, right? If I XOR if I AND not the 1 and the 0, that will actually give me a 1. And if I AND not this one, I would get a 0 as well, right? Again, when I say I'm bad at this, I'm not kidding. So correct truth table. So no, they're not the same there, right? You get one difference in them, which is that so in this case, we're doing like, this was the original value. And what we're trying to do is clear out where it's a 1. So if the 1 is set here, I want to clear it, which is what's happening. Whereas if I don't have it set, I don't clear it. And so you can see the case where it's wrong is that if I was trying to clear this, I will accidentally set it. So it's almost what I want, right? But not quite. So that comports with my recollection, which was sort of that, no, you can't do that, because I always write it like this, and I don't write it like this. But I just wanted to underscore that, because sometimes, you know, one of the things I say a lot on Handmade Hero is that I like to show the actual act of programming to demythologize a lot of the stuff about how good people actually are or aren't. Because most programmers I know, or probably all, are bad at some things and make mistakes and struggle with stuff all the time, even the very best people. And I think it's usually good to show that that's true, because I feel like some people may get unrealistic expectations about how good people are, and they're almost always inflating their opinion of how good another person actually is. Yes, there are great programmers. There's no question about that. But even great programmers struggle all the time. And I get to see that because I've gotten to work with great programmers. I think that's one of the nicest things about Handmade Hero style streaming, is that now there's so many people, like you can go watch John Blow's stream, who, you know, I mean, like if anyone deserves cred, it's him in the game industry. I mean, of people who have done game programming, he's like the top, right? You can just watch them make a mistake. And I feel like that's really good, because every time you can watch someone make a mistake, you're like, oh, okay, it's okay. Like, I'm not like bad at this or something. This is just how it goes. And so I feel like the more of that we get there, it's like, yeah, you know, like I've been programming forever, and I still, there's just parts of my brain that are just like, yep, it's never going to learn that. You know, who knows why, just isn't. It's going to have to draw out a truth table sometimes for stuff that you should just know. Like, you should just be able to just do it. And so when people are just starting out and they're like, wow, this stuff is hard, it's like, yeah, it does get easier, but it always is a little hard, right? Like, even with a lot of experience, or even if you're a very successful programmer or anything else, there's always some things, because it's such a complicated discipline, you're never going to be perfect. Like, it's just not going to happen no matter who you are, I don't think. Maybe I'm wrong about that, but I've never seen anyone who can, right? So anyway, long digression, but I just think that's great about streaming programming, because that's one of the things I don't think people see enough. You know, when you post finished code on a blog or something, it's just, you feel like it just came out of nowhere and that person must be awesome. But no, they probably made all kinds of screw ups on the way to that you just didn't see. And so the streaming format's so much nicer because you can see the mistakes. And I feel like that's just really important for beginners to see. So they know that's not them. That's just programming, right? So anyway. Okay, so what I want to do here is I want to be able to get the texture out of this thing. So I'm going to make a texture index. I'm just going to get the index out of it, right? Out of the texture that we're talking about. And so then, instead of using texture.index, I'm just going to use texture index directly. And that way, I can know that it's been masked off and it doesn't have the flag on there anymore, because I don't really want that in there anymore. So now the question is, well, where do I get the handle from, right? And the answer is I get the handle from the get special, right? Where is that guy? The get special texture handle for. This guy right here is where that would come from, right? It's actually this code right here is what that needs to start with. Now, in this case, this kind of becomes redundant. I don't like the construction that I've kind of chosen there because I'm going to end up having to double call this in a kind of stupid way. You'll see what I mean in a second. But when I call texture index from here, that strips off the index here. Now I need to look that up. I want to assert that it's less than the special texture handle count, right? Which we're going to look at a little bit later. And then I want to just grab it. Like so. And so all I'm doing here is saying, all right, peel it off, look up into an array. This is the array that I will allocate later, and we'll go from there. All right, so let's keep going with that. So the reason I was saying I didn't really love this is because the texture index from thing here doesn't really need to happen in that case. So, oh well, I guess maybe I'll do it like this and like this. Okay, that's not so bad. Seems reasonable. So here we can bifurcate the paths. We check to see whether it's a special texture. If it is a special texture, we will handle it by letting the graphics card do whatever crazy gyrations it wants to handle an unusually sized texture that's not even power 2 and it's a disaster and everyone's unhappy. But then most of the time it will not be a special texture, so we can pack it nicely into a texture array and the graphics card will be pleased and it won't get mad at us, right? So we'll do that, and then what we need to do is when we are actually allocating our texture array in the first place, which is down here, so when we do this glgen textures for our texture array, that we need to actually create the special textures as well. So what we want to do in this case is right here, we want to do the same sort of path, right? We want to do a gen textures. We want to say that we're going to generate OpenGL special texture handles. There we go. And we want to do the special texture handle count, which is going to be parameterizable, right? There it is. So however many of these we wanted, we're going to generate an array of them to use. And then what we're going to do is for each one of those, we're going to set the texture parameters on it up front so that we don't have to set them later, because otherwise we'd just be sitting around setting them all the time. So what we're going to do here is bind that texture up right here. And inside here, we'll just say, all right. Loop through all of them. And for each one, get those parameters initialized for us, right? And that just saves us from spewing unnecessary traffic down the bus. I mean, it doesn't matter because the number of textures that we're talking about is so small here. As you recall, the whole point of it is we're only going to have a few of them. We certainly could send them down on allocate. It's not a big deal. But why do something unnecessary when it's unnecessary and it's trivial to do the right way, right? You know, if it was some big deal, I'd be like, yeah, it's probably not worth it. But in this case, it's so simple to do it this way that it's, you know, what can I say? So let's go ahead and get that stuff set up. So gotta actually access the index there properly. So this doesn't need to happen anymore because that's going to be handled in get special texture handle for. That needs to be moved up so that it can be seen here. But otherwise, that's easy enough. And then we need to actually be aware of those special texture handle situations. So in here we've got, or I think we should have, there it is, our texture array. And we've got a texture handle count that we're recording. I think we're talking about this right here, right? And that max texture count is now needs to be augmented with also a 1 for special textures. You know what I mean? So in addition to the GL UINT texture array here, we need sort of 1 for special textures. And so for right now, again, I don't know that I necessarily care too much. Well, I'm trying to think of how we want to do it. So, you know, we do have startup code that sets the texture handle count, I believe. Right, I mean, you can pass that in. I think. So right, because there's a max texture count here. So it seems like we should probably let you say the maximum number of quads you want to handle, the maximum number of textures, and the maximum number of special textures. I can't think of a reason not to do this. So yeah. So I was going to say, let's say that you get to pass that max special texture count. So when you create one of these, you can say max special texture count equals max special texture count, right? And that'll get allocated up for you. I guess one question I have is in terms of the texture opq, do we, yeah, I mean, seems reasonable. So let's just go with that and we'll see if I hit any nastinesses. So that seems reasonable. We can also say max quad texture count, max quad count per frame. And the max quad count per frame here, it's just literally that. This will also let us allocate the array that we need to for storing the OpenGL arrays here. Oh, we still do it. This is actually still here. Right? So that bitmap array, we never stopped allocating it. It's still there. So we can just use that, right? We just don't need as many. Yeah. That's too many. We don't actually need that many. So I might... I'm not totally sure how I feel about that. I'm going to make a note about that. So I'll just leave it this way for now, and we'll deal with that a little bit later. So the other thing that I do need to do here, though, is since we don't know how many of those they've asked for, we do still need to, because we are going to have a max special texture, right? We need to have an array here for those. I also, these are not actually, these actually don't change when the setting, so these really shouldn't be in the dynamic resources section because these don't change. They're actually the same, right? So this is kind of not true. The push buffer memory and the vertex array, bitmap array, index array, all that stuff gets allocated actually one time. So I think that's a little bit more accurate, right? So what we need to do here is specify one of these texture arrays for the special textures. And we also need to have some way of saying how many there are. So once we have those, then in here we can also do sort of the exact same thing we did here, which is say, all right, special texture handles equals GLUint star max special texture count times size of GLUint. And that way you can have as many as you want, and we will allocate those specifically for you. And they don't have to be a fixed number. So when that comes in, that'll just kind of work, right? And we should be good to go. That. This is one line up. And okay. So let's see here. Special texture handle count. This is actually max special texture count. But I think that's otherwise good. That is not an at, that's just a pointer. And so now we're allocating those. The render commands themselves, though, when we do begin frame, is going to need to have the new settings properly accounted for. So we do need to do a couple other things here. We need to set this stuff up. The max quad texture count, the quad texture count, and the quad textures have to be set properly. So the max quad texture count is really just the same as the number of actual quads you can stuff down. I don't know if we saved that anywhere. I hope we did. We didn't. So we'll have to just save that. What I could do is say max quad texture count is actually a thing. And we're going to use it. And then I'll just set that when we actually set the rest of our stuff. Kind of the way that I was going to do it there. So like that. So that kind of sets up the aperture and gets everything ready to go. And so now really what we need to do is make sure we can actually get that from somewhere. We do have sort of a renderer definition here. Don't remember where this is actually specified. We've got some kind of a platform layer specification for it. But let me go ahead and look here. So renderer, where do we specify this stuff? So it is just in here, I guess. Or is the init stuff not in here? All right, so it's in Win32 Handmade. Okay, so it's just this specification here. Yeah, so we can just say max special texture count as additional parameter that you have to provide. And then everybody who was previously calling something there, so this doesn't use one, so it wouldn't care, whereas Handmade Hero does use one. So it needs to say, hey, we're going to use up to 16 of these. In terms of the texture op queue, I really want the texture op queue to have that information in it, but it seems like that may be not that likely, right? Because it's separate. It's just a queue that's separate from the renderer. And so it's like someone would just have to like copy it in there. And I just don't know if that makes much sense. You know what I'm saying to you? So I kind of feel like these should just be separate from it. So I think I'm going to have to not do it that way because it just doesn't, it just feels like I'm shoving sort of stuff through where it shouldn't really go. So I do feel like maybe, you know, maybe that stuff has to be put into a better location. So if the game assets, we're going to have that stored separately, right? Then I just need to pass those down. And I think the way I could do that is right now it could just be a pound define because Handmade Hero is going to use however many it's going to use and it really won't change. So I think that can just be a pound define that's sort of use that initialization time in both places, and that would be fine. So I think that's probably fine, and wouldn't really cause a problem. So inside here where we actually do the initialization, I feel like that's okay. So, you know, yeah, I mean, I think that's what I would go with for now. Because I don't really see much point in doing it a different way. So here you just say, look, the normal texture handmade we could just set those that way. Maybe in the future we make them be more dynamic than that. But the important part to me is that the renderer can be started up in either way. I just need to make sure those are the same across each one, because then in the future we could do it a different way if we want to, and make that into a more parameterized thing, right? So that's probably fine. So inside handmade.h, I'll just make some pound defines for this at the moment. See what I include inside Win32 Handmade, because that's where it's going to have to get used, right? So much Win32 code. So yeah, I mean, I'm not really sure exactly where this should live. It's something that we're probably going to want to fix. I just don't have a clear idea of how that would get passed through at the moment. It could be something that comes in the game input or something like this, or in the game, sort of the way the game gets started up. But I'm just not sure. So I think this will probably be changed eventually. But that's roughly what it would be currently. So all right, there's quite a bit of stuff that has to happen there, and so we kind of gotta look through this a little bit more carefully here. But that's basically what's going on. What happened here? I should, hold on a second. Sorry, I just want to switch to debug mode so we can have an easier time. So let's just take a look here. What's our max? Special texture count? 16. What's our special texture handles look like? Oh. So did that not get allocated? I thought I did. I probably just made a slight mistake there and didn't, even though I thought I did. Ah. This is in the wrong place. That is the problem there. So these probably should happen before the OpenGL init, right? I should probably do them here so we can have everything allocated up that might get used. So there, that now can operate properly. So it looks like, you know, nominally working, right? Like it didn't crash and it's showing textures. But we don't really know to what extent it's actually working, right? We haven't like looked at any of that stuff. So what we probably want to do now is start like stepping through some of that code and make sure that we Like, and we're kind of out of time for today, so maybe I'll do it tomorrow. But it looks like it's not correctly picking special texture here, because you can see that index does not have the high bit set. So yeah. Looks like that's our primary problem here. Let me just quickly fix that since we know it's a problem. And then we'll wrap it up for today and we'll do the debugging work tomorrow. Since everything still runs, just not the cutscenes, which is the same way we started the day, so it's not like we're breaking anything. We just haven't finished fixing it. So yeah, special textures. Dimensions require special textures takes the width and the height. Looks to see whether or not it needs to use a dynamic one. Generates a special texture handle here based on that. So I don't see anything obviously wrong there. Let's take a look in the debugger real quick, just to see what's going on with that. So let's go into load bitmap here. And just take a look at what happens when it goes through this code path. So, you know, we're looking in here and we've got a width of 144, a height of, yeah, I mean, you see what's going on there. And so, you know, all of these for the initial set of textures are all going to be, you know, they're going to be small. This is fonts and junk probably, right? So that does its thing. And then when we go to the cutscenes, we need to take a look and see what's happening on the large ones. Is something not tagging those textures properly or what? So here's our bitmap. The width and height are obviously too large. Oh, well, that's initial screw up. That should be an or, right? Not an and. You know what? Alan Webster was talking about this very bug. Maybe not this one, but a closely related bug. In this case, though, it doesn't matter because they are both larger than 512. So the result is true. So it comes in here. It says, look, let's get a special texture for texture handle 0. It says, all right, let's compute a result by ORing in the texture bit. There it is. Out pops a texture handle. It's that, right? So then we're going to do refer to texture. And it sure seems right. So I wonder if it's just the and. Let's see what is the dimension we actually crash on? Because maybe it is just the and. Yes, it's just because the height was lower. So it was just because of this and should have been an or there, right? Yeah, so it did look like the other parts were working okay. Now, I don't know that they actually are, but, you know. What is this? Why are we still U16ing that? So that's not right. That... Oh, wait a minute. That is probably because we pack it into 16 bits instead of 32 for setting it down. So that's actually fine. Oops. This assert doesn't actually catch the bug, any particular bug, so it's actually fine. What we want to do here is sort of say, like, this. So once you peel off the special handle, like, right? Because if you do want to pack it into 16, you totally can. It's just you have to have peeled off the special handle. Otherwise, you'll think that it doesn't match anymore because, hey, a 16-bit number can't equal the 32-bit number, right? So, that is not good. So index array offset is bogus. So I said we were going to debug this tomorrow. I guess I lied. I'm just debugging it now. Probably because these have all been really obvious bugs, so you just tend to want to fix them. We probably changed the meaning of this. Although I can't say that it looks like we did. So the entry just looks straight up bogus. Whereas nothing else does. Well, that kind of does. That's not a special texture. So it does kind of look bogus, actually. This, on the other hand, looks fine. So it's not total garbage, but it's kind of garbagey. Let's take a look here at what is going on real quick. I would just like to see. So we set this up to be the quad texture count 0, max tog quiz, all that stuff makes sense. Index array and all that is good stuff. Looks good. Get current quads. Looks at the batching here. If it can't fit the number of quads, it'll reset. If it needs a special texture, it will reset. And if it has to allocate, why is it not setting the index array offset there? So this may have just been a bug we had before that didn't rear its head till now. Because it looks like we never use index array offset, actually. And it was probably just getting set to 0 by happenstance, I'm guessing. I don't know if that's exactly correct, but it certainly seems like we should be doing that. And if you look at how we're using it here, right, we are doing that. Now this needs to be changed slightly. So we do need to have that routine work a little bit differently, because now those arrays don't line up one-to-one, right? And so we do kind of need to say, well, all right, let's just do the index array directly over the quad count, and we'll take the index array offset and add it in, right? So right here, we'll do that. Because this needs to be able to do the div by 6 there. Furthermore, it's unclear that we really want to do that. I mean, why not do this, right? So let's loop over the quad count. The index is just going to be the offset of the quad index times 6. Right, so we just say, look, start where we're going to start, and for every quad we go 6 forward. Then that way this is just a direct index into quad texture, is no divide. And then the draw elements call just works using the same stuff we were using before, right? So we just say, yeah, like that. Seems saner to me. It was a little bit contorted before. So that must have just been a bug. We just overlooked it when we finished last time, a month ago on our last stream, before a break. We probably just overlooked that because we were only ever doing one dispatch, because the entire game was being drawn with a single dispatch, right? And so now that we're drawing multiple dispatches, we need to do that. Now, unfortunately, we aren't seeing anything, which is not great, but we're not crashing. So now we know we are actually at least using the textures a little bit more correctly. My assumption is that probably we just have a slight few issues with how we're maybe submitting the textures or something pretty basic. It probably won't be too hard to finish this off and get to a point where this is working. But now I probably should save it for another day, because I expect this will now be somewhere we got to kind of look at the OpenGL a little bit more carefully, which, as you know, is always a little bit of a adventure. So probably don't want to do too much more. Let me just take a quick look. Where we set these up. Where is my... There it is. Yeah. So, I mean, it seems reasonable. So, yeah, I don't see anything obviously wrong. So, I'm suspecting we'll have to do a little bit more hardcore checking on that. Just to make sure. Let's set a breakpoint in here real quick. Just take a look at what it looks like. And again, that path never gets hit. It's only in the cutscenes. All right, so we take a look here at the index that we're drawing. It's 0. We'll take a look at the texture. It's 0. That's width and height of 0. I'm not sure. Doesn't quite sound correct here. Oh. Hey, one thing we might want to do is when you actually push a quad on there, you might want to push one onto the, you might want to actually record the texture that you're using, which we did not do. Oops. So, yeah, what we could do here is say, look, we get the current quads. We can say if it's special. Push it on there. Think we can just do this? I think. I do not want anyone to quote me on that because it's sort of a vague feeling I have that I can do that. It's sort of just a premonition rather than a actually scientifically thought through thing. That looks a lot better. Well, it looked a lot better in the code. It doesn't look any better in the game. I said I was going to stop programming and I didn't, did I? I lied. I completely, it was like a bald-faced lie. So I really will stop now. Sometimes it's a little obsessive. You know what I'm saying? So this is binding texture, drawing elements. There's an unsigned short of the index of 0, and we did bind those, right? So they should be correct. All right, so I'll leave it there. I'll leave it there. Let's go to a brief Q&A, and I will leave it there. We will come back to it. I keep saying I was going to stop. I didn't stop. We will come back to it tomorrow, and we'll debug why we're not getting. I think we've done everything else, but we did make a lot of changes. Commands should be entry on line where it breaks. Commands was left over. Right, you are. I still don't think that helps us because it's probably the first one, but so I think we're still probably broken. But that's you're right. Yeah, we still I think should have seen one bitmap. So I think we probably still have another bug, unfortunately. I wish that were the only one, but I don't think it's enough. Good catch though. Yeah. because we would have seen one bitmap is what would have happened in that case. We would have always drawn with bitmap 0, right? Probably would have seen more, actually, now that I think about it. But, yeah, just not quite. Not quite. It was a bug, though. Just not the only bug. All right, so if we have no questions, then we're done. We will be back tomorrow for more fun and James. How do you handle attributes and variants for your GLSL? So we aren't really doing much in the way of parameterized shading. So we don't really have much in the way of what you're talking about. Really all we do is we just have a couple shaders. I think we have like 4 or 5 of them that we actually use. And we just set up the parameters manually in the code, right? So we don't really have, like, if you had like 100 shaders or whatever, you wouldn't be able to do what we're doing, I don't think, because we're doing something much more simplistic. So you can see here, like, we just grab these out and then we later just set them when we go to actually do that dispatch. And that's because we're fundamentally not a GLSL party. Like, we only use GLSL to replicate the things we would want to do in our software renderer. Pretty basic stuff, right? Like, so if you were like really shader heavy and had tons of stuff happening in shaders, you would need more than what we're doing. And yeah, and it's ugly. Believe me, it's ugly. It's one of the things that C does worst, is that kind of thing. C and C++, one of the great failings of C and C++, you can see it right in there, where it's like, oh, we have this other thing that wants to be able to take some text that also uses structs, and we should be able to just like use the metaprogramming features of a language to make it so we define the struct once and then just call it and it all just works. But instead, it's this whole ridiculousness of like having to do like some tricks with includes if you want to do that, or you have to define it in 2 places, or you make a preprocessor. It's like, again, a real language for games, which we will get someday, will not have any of these problems. When we leave C++ behind, maybe we're on JAI. JAI can already do this if it wanted to, right? Because it's got metaprogramming, it can introspect, it could generate the shaders as part of the compile step. JAI can already do all of this stuff if you wanted it to, right? And that's just the beginnings of John's language. It's not even publicly out yet. And it can already do this stuff. So you can already see, like, if somebody who knows what they're doing goes and makes a language for what we want to do, it's not that difficult to see where it goes to. But the C++ people, they don't think about like what you actually do when you're programming. Like, they don't think about how to make programming work better. They think about weird esoteric things that they like to argue about that have no bearing on programming efficiency, right? So you end up with a language that has a spec 80 miles long and can't even do basic stuff that JAI could do like the first day it was, a language, right? And that's just, it's where your priorities are. It's what you focus on, right? So. Did InsoBot just say Domo Arigato, Mr. Compiler? Because if so, that is the new high watermark for artificial intelligence. What are the stats on your glasses? The stats are that they were like the only pair of expensive glasses I ever bought, and it was my first pair of glasses, and I've never gotten a new pair of glasses. I tried to buy like a cheap pair one time, and they were so much worse that I've always kept using these. It's just like some kind of titanium frame or something, just little wire that just connects, and they're great. They also have like, because they're bendy like that, they never, like, you can go rock climbing with them and they will not fall off because they're like looped almost like a sport glasses are looped. So, you know, I mean, maybe there's certain things you could do like boxing or something where they would come off, although you wouldn't want to wear them boxing. But, you know, even stuff where you're hanging upside down, they never come off, which is great. All right, I'm gonna wrap it up. Thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along the series at home, you can always go to handmadehero.org and pre-order the game because it comes with the source code so that you can follow along with what we do here every day and play around with the source yourself. We also have some other stuff. There's a watch page you can go to watch old versions of the series, like old episodes and stuff. It's got a great search page too, so you can find stuff. We also have an FAQ if you just have basic questions. And we also have the Handmade Fund, which we use to fund community projects. So if you're interested in supporting things like our episode guide or Handmade Network, that's a good way to funnel money to those projects. That's it for today. I'll be back tomorrow when we'll finish debugging that. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.